So today we're going to be talking about the L'Hopital's rule, and when we're using the L'Hopital's rule, this helps us to solve limits that result in indeterminate forms like 0 divided by 0 or infinity divided by infinity. So the first thing we're going over is just a reminder of what an indeterminate form is. So the indeterminate form is we have a limit as x approaches some value of c, and we have a function of x over another function of x. And what causes the indeterminate form is if we result at the end of the limit is a 0 over 0 or infinity over infinity. Because if we get this answer, we can't tell what the limit is actually going to do. So the way that the L'Hopital's rule works is when we get a function divided by a function and it results in 0 divided by 0 or infinity divided by infinity, we need to take the limit again as x approaches c still, but instead of f of x and g of x, we're going to do f prime at x and g prime at x. So we just take the derivative of the top and the bottom. So for example, if we had the limit as x approaches 0 of our function of sine of x divided by x. Well, when we know that if we put in x equaling to 0 of sine of x, that's going to be equal to 0. And if we substitute 0 in for x, this will just become 0 over 0. And since this is going to be our indeterminate form, we know that we need to use L'Hopital's rule. So again, we're going to take the same limit from x approaching 0, but now we need the derivative of the top and the bottom, which gives us our new function of cosine of x divided by 1. And now, when we substitute in our x approaching 0, this will change to cosine of 0 divided by 1. And cosine of 0, unlike sine, if we have our graph here, sine will start at 0 and go up. However, cosine will start at 1, which means that we'll get our answer of 1 divided by 1, or our limit equaling to 1. And to check the answer, if you go in Desmos and put in sine x over x, you can see that when our x approaches 0, our answer is going to be equal to 1. So the first question is question 8, which is the limit as x approaches 3 of x minus 3 divided by x squared minus 9. So when we put in x as equal to 3, this will give us 3 minus 3 divided by 9 minus 9, which is 0 over 0. And since we get 0 over 0, we know we need to use the L'Hopital's rule. So when we take the derivative, this will just become the limit as x approaches 3. And since our numerator has x minus 3, the minus 3 will just become 0, since it's just a constant, and x will become 1. And then our x squared will become 2x, and our minus 9 will just become 0. So this will just become 1 divided by 2 multiplied by 3, which is 1 divided by 6. So the limit as x approaches 3 of x minus 3 divided by x squared minus 9 is 1/6. Our next question is number 11, which is the limit as x approaches 1 of x to the power of 7 minus 1 divided by x to the 3 minus 1. So when we plug in 1, this will give us 1 to the power of 7 minus 1 divided by 1 to the power of 3 minus 1. However, 1 to the power of anything is still 1, so this will just give us 1 minus 1 divided by 1 minus 1, which is 0 divided by 0. So as soon as we get 0 divided by 0, we know we need the L'Hopital's, which is going to be the limit as x approaches 1. However, the derivative of the numerator makes it 7x to the power of 6, and then the minus 1 will go away, divided by 3x squared. So now, this will, when we plug in our 1, this will become 7 multiplied by 1 to the power of 6, divided by 3 multiplied by 1 to the power of 2. And since again, 1 to the power of 6 and 1 to the power of 2 are both 1, and any number multiplied by 1 is itself, this gives us the limit as equal to 7 divided by 3. So now we have question 12, which is the limit as x approaches 4 of the square root of x minus 2 divided by x minus 4. So this will become the square root of 4 minus 2 divided by 4 minus 4, which is just 0 over 0. So now when we do the L'Hopital's rule, this will become the limit as x approaches 4. So when we do the derivative of square root of x, to make it easier, we'll make it x to the power of 1/2. And then this will become 1/2 x to the power of negative 1/2. Or this will simplify to 1 over 2 square root of x. So now here, what we're able to do is we're going to change this to 1 over 2 square root of x divided by the derivative of the bottom, which just becomes 1 as minus 4 just becomes 0. So now this will, when we plug in x equaling to 4, this will be 1/2 multiplied by 2 times square root of 4, which is 2, and divide that by 1. So now this will give us 1/4 divided by 1, which we'll bring to the top, which will give us 1/4. Next up we have question 16, which is limit as x approaches 0 of x squared divided by 1 minus cosine of x. So when we plug in 0, our x squared will just become 0 squared, and 1 minus cosine of 0, which will just be equal to 1, which will give us 0 divided by 0. So now when we want to take the derivative of the top and the bottom, it will still be the limit as x approaches 0, but our numerator will be 2x, and our denominator will change to negative sine of x. We'll change to sine of x. So now when we plug in the 0, sine x, when we plug in our 0, we'll still get 2 multiplied by 0 divided by sine of 0, which will be equal to, again, 0 over 0. So now when we get 0 over 0 for the second time in a row, what we do is we take the derivative one more time. So again, we'll get the limit as x approaches 0. However, our 2x now will just be 2, and our denominator will be cosine of x. So this will give us 2 divided by cosine at 0, which is 2 over 1, which gives us our final answer of 2. So whenever you get 0 over 0, no matter how many times you do it in a row, you just take another derivative of the numerator and denominator until you get your final answer. Now we have question 24, which is the limit as x approaches 0 of 8 to the power of x minus 5 to the power of x, all divided by x. So when we plug in our 0, it becomes 8 to the power of 0, minus 5 to the power of 0, all divided by 0. And if you remember, anything to the power of 0 just becomes 1. So this will just be 1 minus 1 divided by 0, which is 0 over 0, allowing us to use the L'Hopital's rule. So now we get the limit as x approaches 0, and our 8x will just become 8x, 8 to the x ln of 8 minus 5 to the x ln of 5. And that will be divided by 1. So now what we're able to do is this will just, when we plug in our 0, we can ignore the denominator since it's just equal to 1, and this will give us 8 to the power of 0 ln of 8 minus 5 to the power of 0 ln of 5. And this will give us 8 to the 0 is just 1, and 5 to the 0 is just 1, so this will just give us ln of 8 minus ln of 5, which simplifies to ln of 8 divided by 5. So the way that we took the derivative of our 8 to the power of x and 5 to the power of x is if we have any number that's a constant to the power of a variable, whenever we're taking the derivative, it's going to be that constant to the power of the variable ln of the constant. So now we have question 26, which is the limit as u approaches infinity of e to the power of u divided by 10 divided by u to the power of 3. So the first thing we're going to do here is test to see what would happen if we plugged in infinity, which would be e to the power of infinity divided by 10 divided by infinity cubed, which is just going to be equal to infinity over infinity, which is the other thing that we're looking for L'Hopital's rule. So now we need to take the first derivative, which is going to be the limit as u approaches infinity. And when we're taking the derivative of e of u to the 10, it'll just be e to the power of u divided by 10, and it's going to be multiplied by 1 divided by 10. And then our denominator is going to be 3u squared. But then if we plug in our infinity again, this will just be 1 over 10 multiplied by e to the infinity by 10 divided by 3 infinity squared, which again gives us infinity over infinity. So we need to take the derivative again. So now we get the limit as u approaches infinity of 1 over 10 multiplied by 1 over 10 multiplied by e to the u over 10 divided by 6u, which if we plug in, we'll get 1 over 100 multiplied by e to the power of infinity divided by 10 divided by 6 multiplied by infinity, which again will be infinity over infinity. So we need to take the derivative one more time, which will give us the limit as u approaches infinity, and this will be 1 over 1000, because it will be 1 over 100 multiplied by 1 over 10 again, multiplied by e u divided by 10 divided by 6. But when we plug in infinity here, we get 1 over 1000, but we still get e to the infinity over 10. And that will be divided by 6, which will just give us infinity over 6, which means that our limit, even though we did all the L'Hopital's rule, our limit will still be equal to infinity. Now we have question 34, which is the limit as x approaches 0 of e to the x plus e to the negative x minus 2 cosine of x divided by x sine of x. So what we need to do is test it at point 0, which is going to be e to the 0 plus e to the negative 0 minus 2 cosine of 0 divided by 0 sine of 0, which gives us 1 plus 1 minus 2 divided by 0, which is just going to be 0 divided by 0. So we know that we need to use L'Hopital's rule. So here we get the limit as x approaches 0, and then the derivative of e to the x is e to the x. The derivative of e to the negative x is going to be negative e to the negative x. This will be minus 2. This changes to sine x, and this changes to plus. And it'll be divided by, and now since it is two functions multiplied together, we need to do the product rule, which is going to be 1 multiplied by sine of x plus x cosine of x. So now when we test it at point 0, we get e to the 0 minus e to the negative 0 plus 2 sine of 0 divided by sine of 0 plus 0 cosine at 0, which is going to be 1 minus 1 plus 0 divided by 0 plus 0. So again, we get 0 divided by 0. So we need to take another derivative. So this will get us the limit as x approaches 0, and this will be e to the x, and this will change sign to be plus e to the negative x again, and this will be plus 2 cosine at x, divided by sine x will become cosine at x, and this will be, now we have to do the product rule, which is plus 1 multiplied by cosine at x. This will be minus x sine at x. And now when we plug in 0, we'll get us e to the x, which is 1, plus e to negative x, which is 1, plus 2 cosine at 0, which is going to be 2, divided by cosine at x at 0 is going to be 1, plus cosine at x, again, is 1, and then this will just become 0, minus 0, which will give us 4 divided by 2, or the limit will be equal to 2.